Okay, so you have a new problem and you've been given an order for 340 micrograms of a medication. The vial that's supplied on your unit has 2 milligrams per milliliter in that vial. How many milliliters are you going to give the patient? So again, we're going to start with the same steps. Number one, write down your given. So what have we been given here? We've been given that we're given 340 micrograms of medication, and we've also been given how it's supplied, which is 2 milligrams per milliliter. Step two is write what you need. What do we want for our answer? We want it in milliliters. Step number three, find one of the givens that also contains the answer. So we have milliliters and milliliters. We always want to set it up so that the answer we're looking for is on top, so just like we've done here. And then you want to eliminate the things that you don't need. So we don't need milligrams, so we're going to get rid of those. But how do we get rid of milligrams when we're only supplied micrograms? Well, we know that our unit conversion charts that we gave you on the Moodle that you can use tell you that in 1 milligram there's 1,000 micrograms. So we're going to get rid of a milligram by changing it to micrograms. Now we have micrograms on the bottom. We can get rid of the micrograms on top, which we were given here. And we always put 1 for our placeholder at the bottom. So now we've canceled out everything and we're left with what we were looking for, milliliters. So now we just do our math. So we multiply across. 1 times 340, 2 times 1,000 times 1 is 2,000. And 340 divided by 2,000 comes out to be 0.17. And as we discussed, anytime that you are rounding in our course, you're going to round to the tenths place. And because 7 is 5 or greater, you're going to round up to the next tenth, which is 0.2. So for this patient, you would give 0.2 milliliters of medication. Okay, so you have an order for 0.3 milligrams of a medication. And you go to your Pyxis or your medication cart and you pull it out and you've only got 25 microgram tablets. How many tablets are you going to give this patient? So we go back to our same process. Write down what we've been given. We've given 0.3 milligrams and we've been given 25 micrograms. And we want to know how many tablets. So our answer is written in tablets. So, no, you're good. So then we're going to sit down and say, what do we need first that comes with the same unit? And that is 25 microgram tablets. So we're going to get rid of milligrams. So now we're going to have to do a unit conversion. Just like in the last problem, you know how many micrograms are in a milligram? 1,000. So we're going to get rid of micrograms by changing it to milligrams. And now we know we can get rid of milligrams because we have a similar unit. So 0.3 milligrams. So now we've gotten rid of micrograms, we've gotten rid of milligrams, and all we're left with are tablets, the number of tablets we need. So we're going to do our math. So 0.3 times 1,000 is 300. And 25 times 1 times 1 is 25. And 300 divided by 25 comes out to be 12. So for this patient, if this is actually what you were supplied, you would be giving 12 tablets. Hopefully nobody ever has to give 12 tablets to a patient of one medication, but in case, this is how you accomplish that. So a couple of important things we're going to talk about on this one before we get really started. Remember, by definition, still, though most of us have gone to work in 12-hour shifts, first shift is going to be 7 to 3, second 3 to 11, and then third is 11p to 7a. Remember, your military time is going to be important. You're always going to document in that form. And then again, your unit conversion charts that you're going to need to utilize, milliliters to ounces, ounces to cups, cups to gallons, those type things. And then also you looking at those metric measurements. So go ahead and print that out. Keep it handy. You're going to use it throughout the math problems. We know you're going to be using that. That's fine. Print it out, have it readily available, and use that as you're practicing. Okay, so right now we're going to calculate INOs for a patient for your shift. So Jane came in this morning and she drank an 8-ounce Coke. Then at 10:30, she drank 1 cup of water, and she's receiving normal saline through her IV at 75 milliliters an hour. This afternoon, she got up at 13:30 and voided 400 cc's. So we're going to calculate how much fluid she took in, how much she put out, and determine what her fluid balance is. So let's put all of her ends here. So first off, we have 8 ounces of Coke. Then we have 1 cup of water, and we have 75 milliliters per hour of normal saline. So a couple things. First off, we talked about you need to have that chart ready. So how many ounces are in a cup and how many milliliters are in an ounce or how many milliliters are in a cup. So first off, we'll start out, we know that there are 8 ounces in a cup. So these are going to be the exact same. You just have to remember to look at your measurement types. And in 1 ounce, there are 30 mLs or 30 cc's. And that will come out to be 240 because 8 times 30 is 240. Same thing here. 1 cup is 8 ounces. 8 times 30 is 240. Now we're running our fluids at 75 milliliters an hour. How many hours are in your shift from 0700 to 1500? 8. So you've got 75 milliliters running continually for 8 hours. So that's 600 milliliters that she's received IV. So let's total that up. So she's received 1,080 milliliters in today. And then what are our outs? We know that she voided at 13:30 for 400 cc's. So if the question that's posed to you is what is her intake for today? You've got your solid answer. If the question is what is her outtake or output, you have your answer. Then if you want to know what's her fluid balance, we're going to just take and measure the difference between the intake and the output. And so we have 1080 minus 400. And that balance is how much she has. And because it's a positive number, 680, that means that we know as of this point, she has retained 680 milliliters of the fluid that she's received. If that number came up to be a negative, maybe she's getting Lasix or a diuretic, and now we know that she has put out more than she's taken in, and we're getting rid of some of those fluids. So that's exactly our goal. You're going to do this a couple of times throughout the course and in tests, and this is something you're going to apply daily in practice. So make sure that you're comfortable with I's and O's. If you're not, please notify us so that we can help you. Okay, so one of the things that's really important that we need to discuss is making sure that you have accurate weights on your patients because a lot of your medications are going to be weight-based. So those daily weights are very important, as well as remembering and reviewing your approved abbreviations. I know a lot of us went to school when things like MSO4 were acceptable for morphine, and it's no longer because it can be confused with magnesium sulfate instead of morphine sulfate. So we want to make sure that you review those because those will be things that you will see and terms that you'll see on quizzes and tests going forward. So make sure that you remember what BID is, PO, AC, HS. Review all of those, and if you have questions, please let us know. So for right now, let's look at this patient, and she weighs 156 pounds, and she's got pneumonia, so they've ordered to give her Zosyn at 5 milligrams per kilogram PO. So the question is, how many milligrams are we going to administer to the patient? So we're going to start out the same exact way. Write down what we've been given. We know she weighs 156 pounds. We know that we have a medication that comes in 5 milligrams per kilogram. So our answer is how many milligrams we're going to give. So we're going to set up our problem the exact same way. First, we're going to find a given with the same unit of measure as our answer, which is going to be the 5 milligrams per kilogram. And then we're going to make sure that we write it so that milligrams is on top. So we have 5 milligrams per kilogram. And now we need to get rid of kilograms. But we've got our weight in pounds. So we know that we're going to put kilograms on top, and 1 kilogram is going to be equal to 2.2 pounds. Well, now we can mark out kilograms, and now we need to figure out where we have pounds. We have it here, so 156 pounds, and we're going to use 1 as our placeholder. And so now we're going to do our math all the way across. 5 milligrams times 156 pounds is going to come out to be about 780. And then we have 2.2 times 1, so that's 2.2. And 780 divided by 2.2 comes out to be about 354.545454 forever and ever. So in this equation, we were going to ask that you round to the whole number. So if you were to round to the whole number, 5 would go up to the next mark, so that would be 355. So you would administer 355 milligrams to the patient. Now, using everything that we've already discussed and everything we've already applied, if you need to give tablets or milliliters, you could just take this to the next step, doing exactly what we've done. We know we have 355 milligrams and we have 50 milligram tablets. So how many tablets would you give? And you would set this up exactly like you've been doing. You would just put your 355 milligrams and how many milligrams in a tablet, and you work that out and find out it's about 7 tablets. So practice some more of these problems. We'll give you some pages in your book that you can utilize to help you practice if you need to. And then again, always reach out to us for future questions. I think that's about all we need to cover for this video. If you have additional questions, let us know. If it's appropriate for your course, we will be making a video on IV infusions and calculating IV drip rates and things like that. At this point, that's not appropriate for some of the courses, and we don't want to overwhelm you with too much math at once. So we're going to start here, and then if we need to, we're going to add on that portion if it's appropriate for your course. So if you don't receive that, don't feel worried. That means that you don't need it right now, or you don't need it at all. So take that as a blessing. All right. So we're looking forward to working with you. Have a great day, guys.